difficult to think of two fighters that contrast more sharply than the P-38 Lightning and the Mitsubishi Zero. The Zero has an empty weight of only 4,000 pounds. That's less than a lot of today's sport utility vehicles. At almost 13,000 pounds, the P-38 is over 3 times as heavy. But the P-38's main designer, the legendary Kelly Johnson, incorporates several innovative features into the Lightning that allow it to fight on more than equal terms with the Zero.
Chris, good to see you again, buddy.
Good to see you, Max.
So here we are now at the Lockheed P-38 Lightning. For its time, it was really radical. I mean, it's got a very different shape to it.
It was an incredibly radical design.
One of the very unique things is that it's got 2 engines.
It was incredibly unique, especially for the 1937 time frame. You look at all the other aircraft like the P-36 and the P-35 and the P-40, which had an engine up front, a fuselage, and a conventional wing. Kelly Johnson was presented with a directive from the U.S. Army to design a high-altitude fighter. At the time, we were the leading country that produced turbo superchargers. So Kelly Johnson had to design an airframe that had 2 big engines and 2 turbo superchargers to give the performance they needed.
Kelly sketched out several different potential layouts for his new fighter before finally deciding on a twin boom design to save weight.
He could put the engines in their nacelles with their superchargers, have this center section, which they called the pod for the pilot, and the armament, and save a ton of weight.
The P-38's turbo superchargers are used to improve the fighter's high-altitude performance.
These engines would be good and maintain power up to about 12,000 feet. For a high-altitude fighter up to 25,000 feet, essentially what you do is just like on a turbocharged car, is you're going to take air, pressurize it, put it into the carburetor, and maintain a sea-level pressure in the carburetor so the engine can maintain power.
The Zero also has a supercharged engine. But unlike the Lightning's turbo superchargers, which are driven by the exhaust gases from the engine, the Zero mounts a regular supercharger, which is driven directly by the engine's crankshaft. The other difference is that the Zero's supercharger is adjusted to maximize engine performance up to about 15,000 feet, whereas the P-38's turbochargers are tuned to keep the engines churning out max power up to 25,000 feet.
Most of the fighters from other countries had the same issues in that the fighters were limited to 12,000 feet and lower to maintain their performance, whereas we now had bombers, the B-17, for example, had the turbo supercharger and was flying in the 20,000 to 25,000 foot region, and now we had a fighter that could go up with the bombers.
So the Lightnings had the luxury of being up there with the bombers, and they're up there smoking their lucky when all the other fighters are down there anchored down low and they can't get up to get them in case they want to target
Exactly
them.
right. And one of the main things in fighter pilot history is from day one is try and get the altitude, and this airplane could do it.
Amen.
The P-38 is one of the first U.S. fighters to reach a top speed of over 400 miles per hour in level flight. It's even faster in a dive. This pushes the plane into a flight envelope near the speed of sound that designers at the time know very little about.
What the Lightning pilots were finding is as they got closer and closer to the speed of sound, up toward 0.9 Mach or so, the shock wave would build up, and now they couldn't pull out of the dive.
The problem is called compressibility. It forces the air to split away from the tail's horizontal surface, called the elevator, denying the elevator crucial airflow to work properly. Not a good thing when you're going downhill fast.
Lockheed solved this 2 ways. One, they limited the airspeed up high, but then Kelly Johnson's design team in 1943 came out with a speed brake system, which would have been right here. They called it a dive flap. It was about 2 feet long. It came down about 8 inches. It was hydraulically controlled, and if the pilot found himself unable to recover from a dive, he just deployed this dive brake. It would change the center of pressure of the aircraft and allow elevator control so he could pull out of his dive.
So it really didn't actually attempt to slow the plane down. All it was trying to do was to change the airflow over the wing.
It changed the airflow just enough so that the elevator would have authority.
What a great innovative solution to a really serious problem for those guys back then.
That whole design team of Kelly Johnson was awesome.
The design team that builds the Zero has a very different set of requirements. Instead of an interceptor that's optimized for high altitude performance, their goal is to construct a medium to low altitude dogfighter. One of the keys to their success is the Zero's wing.
Okay, Steve, so talk to me a little bit about the wing on this Zero. It seems to me like it's a fairly fat wing and a big wing for an aircraft that's actually fairly small.
Well, you know, by design, they're trying to give an airplane a low wing loading, so you have a lot of wing area versus the weight.
This creates a disadvantage in the Zero's top speed. That's because the greater wing area increases the plane's friction with the air, called drag.
But the advantage you have is when you pull G's and start making turns, you don't lose as much energy. There's a lot of lift of that wing.
Yeah, so more maneuverable when you're in a turning dogfight, but it really hinders your top speed.
Exactly, yeah.
Another feature of the Zero's wing that helps make the plane such a superb dogfighter is its enormous aileron.
The ailerons travel almost 3/4 the length of the wings. It's a pretty big aileron.
Oh, it's a huge aileron. But this is a fabric-covered aileron, and you might understand the reason they're fabric is it's all about weight and structures. If you were to metalize this aileron, then all the hinges have to be heavier because the counterweight of lead to balance the controls are heavier. Then the wing spars get heavier. So anyway, there's a compromise by going fabric, and fabric worked really good, and it was contemporary with everything of that era.
But once you get up towards the higher airspeeds where you have more friction over the wings, more airflow, that can actually probably come back and bite you a little bit.
They balloon up, and then the controls get really weird. These are outstanding rate of roll this airplane has to your high speed. Then they get really heavy. You know, the Zero gets over 250 miles an hour, and it's 2 hands on the stick.
Modern fighters like my F-22 are controlled with a fly-by-wire system. This basically means that all the flight control surfaces, including the ailerons, are moved by a computer-controlled hydraulic motor, requiring no muscle power on my part at all. But the Zero's flight control surfaces are moved entirely by muscle power. As a result, when the plane's airspeed increases and the amount of airflow over the wing's big aileron grows, the Zero becomes extremely difficult to fly. So one of the keys for P-38 drivers like Richard Bong is to keep their speed up during a dogfight with the Zero. Another important factor is to try and put their plane in a position where it can best utilize its concentrated firepower.
And one of the brilliant design features of Kelly Johnson's Lightning is the gun package up here. You've got 450 caliber machine guns and a 20mm cannon that all have concentrated firepower. One of the genius designs about this is that you didn't have to fire through propeller. An aircraft that had that feature where the machine gun shot through the propeller had an interrupter gear. That's so you wouldn't shoot your own propeller off. When you had the interrupter gear, you stopped the machine gun from firing, and you lost about 25 to 30% of your firepower.
The Zero uses an interrupter mechanism for its 2 cowl-mounted 7.7mm machine guns, slowing their rate of fire. But the aircraft also mounts a pair of heavy 20mm cannons, one on each wing. That's one more cannon than the P-38. And because the Zero's cannons are mounted outside the plane's propeller arc, they do not need an interrupter gear.